This is tutorial 2, question 5, part 4. We have it temperature represented by capital T is given by 9 small t upon 1 plus 9 small t squared. At the beginning of the answer we have the working for the derivative, because the question is to find the values of small t that give a derivative or the rate of change of temperature large T equal to minus 1. Well, if we find the derivative using quotient rule, and quotient rule says if we have f upon g, then the derivative that we can represent with a dashed is given by f dash g minus g dash f over g squared. So in our case f is 9t, g is 1 plus 9t squared. F dash, derivative of 9t is just 9, and then we need times g, which is just the original denominator. Then we need minus g dash. Well, the derivative of 1 plus 9t squared is just 18t. Times f, which is the numerator, so times 9t all over g squared, so 1 plus 9t squared all squared. And we're interested in putting that equal to minus 1. So in the next line we can expand this bracket with 9 times 1 is 9, plus 9 times 9t squared is 81t squared, and 18t times 9t is 162, so minus 162t squared over the same denominator equals minus 1. Next step is to multiply both sides of this equation by the denominator 1 plus 9t squared, in which case the left hand side becomes the numerator, and the right hand side becomes minus 1 times that denominator, so we just put a minus sign outside the bracket, so that should be squared. Now we can bring that negative term across the equal sign, or add that term to both sides, it's the same thing, but if it crosses the equal sign it changes from negative to positive, so we have 1 plus 9t squared all squared. Well, 81t squared minus 162 t squared gives us minus 81t squared, and then lastly we have plus 9 is now equal to 0. This term here, well first of all, follow the hint given in the question to use this substitution, that u equals t squared, and then that turns the equation into 1 plus 9u all squared minus 81u plus 9 equals 0. Two terms squared, well, we can look at just a plus b squared always gives us a plus b times a plus b, which if you work it out is a times a is a squared, so first term squared plus a times b plus b times a, which can be written as 2ab, since ab and ba are the same thing. Last term plus b squared, or the second term squared, so this term here can be expanded. First term squared, or a squared, is just 1 squared, it's just 1. 2ab, so 2 times 1 times 9u is plus 18u. The second term squared, 9u all squared is 9u times 9u, which is 81u squared. I'll just clear some of the screen. So if we continue here, we have 81u squared. 18u minus 81u is minus 63u. Then we have 1 plus 9 is the last term, all equal to 0. Then we can factorise this either using the quadratic formula, which would say that u is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a would be 81, b would be minus 63, and c would be 10. Or we can factorise. Now this is not particularly easy to factorise, but the general process would be to find factors of 81. So we can choose 9 and 9 and match them up with factors of 10. Well, given that we have a minus sign here, it's likely that the factors of 10 would have to be both negative. And of course I've just happened to choose the correct one, so if 9 times minus 2 is minus 18, minus 5 times 9 is minus 45, add those together to get minus 63. But in reality you have to, it's a process of trial and error, because 81 could also be factorised as 3 times 27, 10 could also be factorised as minus 10 times minus 1, and so on. But this allows us then to say that we have 9u, or that this factorises as 9u minus 5 times 9u minus 2 being equal to 0. And that is only true if either 9u minus 5 is equal to 0 or 9u minus 2 is equal to 0. In the first case, that tells us that u must be equal to 5 upon 9. In the second case, u must be equal to 2 upon 9. And from our substitution, we said that u is equal to t squared, and that tells us that t is just the square root of u. So in this case, the corresponding value of t would be the square root of 5 upon 9, and the other one the square root of 2 upon 9.